So let's solve this problem. We have two objects as shown in this figure, M1, M2, given 1 kg and 6 kg respectively. We need to find acceleration of these two objects and the tension in each rope. First of all, as you know, for this kind of problems we should draw free body diagram. So let's start from the first object. No friction. So there is a rope and trying to move it to the right. So we have a tension to the right. Let's call it just T. That's all, and it will move to the right with acceleration 2 times greater than acceleration of the M2. That's why we need to write second law of Newton's second law for the first object. Tension will be equal to M1 times 2A. Why acceleration is 2 times greater, I will explain it at the end of this video, so don't miss it. Now let's come to the second object. Upward we have 2t. Why 2t? Why 2 times greater than the tension in the upper rope? I will explain it again at the end of this video. And the downward we have a weight of this object, M2 times gravity. And we know that this object will move downward, yes, because there is no another way. It will move downward with acceleration A. So according to the Newton's second law, weight minus 2 times tension should be equal to M2 times A. So as you see, we have two equations, first one and the second one. And how many unknowns? Tension and acceleration, only 2 unknowns, so we can solve it very easily. So let's take tension from the first equation and substitute it into the second equation. So second equation, weight minus 2 times T. T is equal to M1 times 2A, which is equal to M2 times acceleration. So M2 gravity minus 4M1A equal to M2A. So it further is just mass, M2A, which is M2 gravity. We can take acceleration out of the parenthesis, so 4 times M1 plus M2. So we know that M2 is 6 kg. Gravity, let's assume it to be 10. Acceleration unknown, 4 times 1 plus 6. 60 equal to 10 times A. So from here, acceleration equal to 6 meter per second square. This is acceleration of the second object, M2. Acceleration of the first object, we know that it's equal to 2A, which will give us 12 meters per second square. What about tension? We need to come back to the first equation, where it states that tension equal to M1 times 2A. M1 is 1 kg, 2 times acceleration is 6. So from here, tension equal to 12 newtons. So now let's come to the first assumption, that we said acceleration of the first object is 2 times greater than the second object. Why? Let's prove it. So first let's draw it carefully. Actual acceleration of the second object is equal to the acceleration of the movable pulley. So I will not draw the first object, I will just draw the end of the rope, which is connected in this way. So here, and the second object is connected like this. This is the second object, will be attached at this point. So now, initially, system was at this, like this. Now let's assume after certain time t, this point where second object is attached shifts to this point, and basically it moves downward for certain distance x. Now question is, how much meter will the first object will move to the rightward? How we can find it? Actually, the length of the rope is constant. Yes, it's not a spring, it will be always constant, so we will use this logic. So length of this rope will never change. Let me make it red. So length of this rope, the upper part, let's call it L1. The length of the lower part, let's call it L2. So when M2 shifts for X, the movable pulley, which is this one, also will shift for X. This distance will be equal to X. Now the end of the first rope will be somewhere here. The question is, for how much meter or for how much centimeter it will move, it will be shifted. So question is x2, and we should find this distance in terms of this x. Then we can compare, we can find out, we can work out the relationship between accelerations. So now initially the length of the red rope was equal to what? L1 plus L2. This should be constant. Length of the rope always constant. So after t time, when rope is here, end of the first rope is here, what will be the length of the rope? So L1 from here till here plus x this part. Yes, so we need to find this length basically. Then length of the rope, it will be upper part L1 plus x. The length below equal to what? L2 minus x2 plus x. So we should add here, so we need to add. So this is a new length of the rope, which is constant. Yes, initially it was L1 plus L2. So now, as you see, L1 will be cancelled, L2 will be cancelled. So x plus x2x minus x2 equal to 0. So from here we understand that x2 equal to 2x. So upper object will be always moving 2 times faster or 2 times more distance. It means acceleration of this object will be always 2 times greater than the object number 2. So from here we can understand that A, acceleration of the object is always 2 times greater. Yes, so from here we can, this is a proof. Now let's come to the tension. Now let's draw again movable pulley. So we know that tension at point is here T. Let's call it T1. Here also it will be T1, and here tension T2. So we know that mass of this pulley equal to 0. Massless. So it means, according to the Newton's second law, total resultant force should be equal to ma. Since mass equal to 0, this part will be equal to 0. So resultant force should be equal to 0. So what is the resultant force in this case? We have 3 forces, T1 plus T1 to the left side minus T2 to the right side. It should be equal to 0. So from here, as you see, 2T1 equal to T2. Tension at the right side will be 2 times greater than the left side.